Hi, today we're talking about CCM6, LCM, and GCF word problems. Some key words that you'll see in the word problem when you're reading them might be least, same, and all. All of those words are pertaining to finding the LCM. If you see greatest, equal, or exactly, those words are keywords for you and should signal you to find the GCF, greatest common factor. Some steps that we're going to do today is first decide if you're finding the LCM, least common multiple, or GCF, greatest common factor. Step 2, decide what method you're going to use. Are you going to use a ladder, a Venn diagram, or a prime factorization, a factor tree? And then solve. So we're going to do 5 problems today. Our first problem. 2 faucets are dripping. One drips every 4 seconds and the other drips every 22 seconds. If a drop of water falls from both faucets at the same time, how many seconds will it be before you see the faucets drip at the same time again? So some key words here. One drips every 4 seconds, the other one drips every 22 seconds. They're dripping at the same time. So we know that the faucets have dripped and the water's hit at the same time. And so basically we're going to count up every 4 seconds and every 22 seconds until we get to a number that is the same for both. That's called a multiple. Just like if I was counting by 4s, 4, 8, 12, 16, 20, and I'm counting by 22s, 22, 44, 66, 88, etc. I'm counting by that number and I want to find the number that they have in common. So that's called the least common multiple. So I'm looking for the LCM. I've got 4 and I've got 22 and I'm looking for the LCM. I like to use the ladder method. With the ladder method, I pull out a factor they have in common. In this case, I'm going to do a prime number, such as 2. They're both even numbers, so they have 2 in common, and then I just divide. 2 goes into 4 twice, 2 goes into 22 11 times. The number 2 and 11 do not have any factors in common, so I'm done. All I need to do is make an L for LCM and multiply. 2 times 2 times 11, well, I know 2 times 2 is 4. 4 times 11 is 44. It's going to be 44 seconds before the 2 faucets drip at the same time again. Easy, right? Let's try another one. Number 2. There are 14 girls and 21 boys in Mr. Rice's gym class. To play a certain game, the students must form teams. The teams must have an equal number of boys and girls on it. What is the greatest number of teams Mr. Rice can make if every student is on a team? How many boys and how many girls will be on the team? So here is my keyword, greatest, and we want every student to be involved. So every person has to be on a team. There's 14 girls and 21 boys. Because it says the word greatest, I'm looking for the GCF. I like the ladder method, so that's the one I'm going to use. 14 girls and 21 boys. I know that the number 7 goes into 14 and 21. 7 goes into 14 twice. 7 goes into 21 3 times. GCF is just the left side of my ladder diagram. So the GCF is 7. So that means there's going to be 7 teams. But that's just one part of my problem. The greatest number of teams he can make is 7. Now we have to figure out how many boys and how many girls are going to be on each team. Well, there were 14 girls, and if I'm making 7 teams, then there's 2 girls on each team. And if I have 21 boys and I'm making 7 teams, there's going to be 3 boys on each team. Got it? Good. Number 3. Mrs. Crafton is making party bags. She has 60 Starburst, 36 Smarties, and 48 bags of M&Ms. She wants to make all bags exactly alike. What is the greatest amount of bags she can make? Again, we're finding the GCF because it says greatest. I've got 60 Starburst, 36 Smarties, and 48 bags of M&Ms. 60, 36, and 48. I'm going to stop here. I want you to pause the video. You choose whatever method you like the best. If you like to make a factor tree, make a factor tree. If you want to use a Venn diagram, do that. Or if you like sticking with the ladder method, go ahead and do that. Pause the video, solve the problem, and when you're ready, push play, and you'll see the answers come on the screen. Okay, I'm going to use the ladder diagram. 2 goes into 60, 30 times. 2 goes into 36, 18 times. 2 goes into 48, 24 times. I'm going to do 2 again. 2 goes into 30, 15 times. 2 goes into 8, 9 times. 2 goes into 24, 12 times. And 3 can go into all of these numbers. 3 goes into 15 5 times. 3 goes into 9 3 times. 3 goes into 12 4 times. So if I'm doing GCF, I'm going to multiply just the left. 2 times 2 times 3. Well, 2 times 2 is 4. 4 times 3 is 12. So she can have 12 bags. Did you get 12 as your answer? Hope so. Number 4. 2 students in class are stacking blocks. Greg's blocks are 4 centimeters high and Daniel's blocks are 9 centimeters high. How tall would their stacks be when they are the same height for the second time? Why don't you again pause the video, decide what you're going to use, what you're going to find. Are you going to find the GCF or the LCM? And then plan out your strategy and solve. When you're done, push play and I'll have the answers on the screen. Well, I'm going to find the LCM in this method, or in this scenario, because if you think about it, they're stacking blocks up high. So I'm going to be counting by 4s and counting by 9s until I get to a certain height that's equal. So if I look at the numbers 4 and 9, they do not have any factors in common. So the only factor they have in common is 1. So what I can do is just multiply them together because their product will be their LCM. So 36 is the LCM. That's how high they're going to be the first time. So for the second time, I can either add 36 to 36 or I can simply just multiply by 2. And the second time around, they're going to be 72 blocks tall. Did you get 72? If you got 36, that's good, but remember, that's just the first time, and then you have to do that twice for the second time. So 72 blocks tall, we've only got 1 left. Here we go. Number 5. As 200 students enter the gym, some students received prizes. Every 6th student received a pencil, every 9th student received a ruler, and every 10th student received a t-shirt. How many students will get all 3 prizes? I underline how many because that's going to be important at the end of our problem. So we have every 6th student, every 9th student, every 10th student. And we want to know how many get all 3. So we, again, are going to find the LCM because if you think about it, we're counting by tens and we're counting by nines, and we're counting by sixes. When we're doing that counting, repetitive counting, up and up and up and up and up, like 10, 20, 30, 40, 50, we're finding the LCM. So I've got 6, 10, and 9. So LCM is really interesting, especially when you use the ladder method, because you see here, these 6, 10, and 9 together as a trio do not have a common factor. But with LCM, as long as 2 out of the 3 have a common factor, I can move forward. So I can look at the 6 and the 9 and say, okay, 6 and 9, those two numbers are divisible by 3. So I can put a 3 out here. 3 goes into 6 twice. 3 cannot go into 10 evenly, so I leave the 10 at 10. 3 goes into 9 3 times. Now looking at the remaining numbers, again, as a trio, they don't have any common factors. But I can find, if I find just 2 out of the 3 numbers that have a common factor, I can pull that out. In this case, it's going to be 2. 2 goes into 2 once, 2 goes into 10 5 times. 2 cannot go into 3 evenly, so I leave the 3 a 3. LCM is making an L on that ladder. So I've got 3 times 2 times 1 times 5 times 3. 3 times 2 is 6. 1 times anything is just that number. So I'm going to bring down the 5 times 3, which is 15. 6 times 15 is 90. So what does this mean? This means every 90th student gets a prize. Not 90 students out of the 200 gets the 3 prizes. Every 90th student that comes along will get all 3 prizes. So if the 90th student gets a prize, then the next person that gets a prize after him is the 180th student. And if I try to find another student, I actually run out of students because I only had 200 coming into the gym. So that's only 2 people that get all 3 prizes. So my answer here is 2 students. 2 students get all 3 prizes. That's how many. The 90 represented the 90th student that gets all 3 prizes. Okay, we're all done here. I hope you learned lots about word problems today.